Sports science, cardiovascular system. To measure your cardiac output, the equation used is heart rate times stroke volume. To calculate your heart rate, you just count how many beats in your heart make per minute. Stroke volume is the volume of blood that gets ejected from the heart per beat. Measuring stroke volume is testable but in a complex way because it will depend on the heart's capacity. If your heart rate increases or your stroke volume increases, then your cardiac output will increase. The values of the heart in non-professional athletes is a lot higher than in professional athletes, as the heart rate is around 70 to 72 beats per minute for non-professionals at rest, whereas only around 30 beats per minute for professional at rest. For stroke volume, non-professionals will have a lower stroke volume as their heart won't be as strong as professionals. For example, the stroke volume at pre-exercise is around 80 to 100 millilitres, but professionals is around 160 to 200 millilitres. The cardiac output would stay the same for both professional and non-professional athletes as stroke volume is increasing. As stroke volume is increasing, there comes to a point where the stroke volume stops increasing when the heart isn't able to fill up in time with the beat. Therefore, at submaximal exercise, this is called plateau, when the stroke volume no longer increases. Therefore, after this intensity, cardiac output then relies on the heart rate in order to increase. The heart rate is controlled by the autonomic nervous system, or the ANS. There are two branches of the ANS, the sympathetic nervous system and the parasympathetic nervous system, or the SNS and PNS. The SNS stimulates heart rate and the PNS stimulates and slows down heart rate. When exercising, the PNS will be removed and the SNS will start to send accelerated nerve to the SA nodes to increase the speed of the blood pumping through contraction. As you're constantly exercising, your heart rate will always increase as you need more and more oxygen for the muscles, and you are producing more and more carbon dioxide, so the circulatory system needs to speed up. When finished an exercise, your heart rate will slowly decrease due to the PNS coming back and sending the vagus nerve to slow down the contraction. Blood pressure is the amount of pressure that is on the walls of the blood vessels, such as arteries, capillaries and veins. The pressure is dependent on the heart pumping out blood into the blood vessels. The value of blood pressure depending on the size of the diameter of the blood vessel. For example, a capillary will have a low blood pressure as it has such a high volume, and the body around the body and the walls of the capillaries are only 1 cell thick. Therefore, high blood pressure may be too strong for the capillaries to handle, so blood pressure will be low. This is in contrast to the arteries, as these vessels will have high blood pressure as these collect blood straight from the heart, which means the pressure that the heart has exerted to release the blood is impacting the arteries. To cope with these high blood pressure, arteries have thick walls as well as elastic muscle fibers to make sure the blood can't leave them. The equation for blood pressure is cardiac output times resistance to flow. The cardiac output is the heart rate times stroke volume, so when it is measured you would times this by the resistance to flow. There are factors of resistance which include viscosity, vessel length and vessel diameter. The viscosity is how thick the blood is, and if it's too thick then it might not be able to flow, which can cause cardiovascular disease. When at rest, a typical blood pressure value should be around 120 systolic and 180 diastolic. As you exercise, blood pressure increases as your heart increases, which causes an increase in your cardiac output, therefore resulting in an increase in your blood pressure. Natural high blood pressure is not very healthy because it might mean you have thick blood or thin blood vessels. It is critical if your blood vessel reaches over 180 systolic and 120 diastolic. The units for blood pressure is millimeters of mercury. So if your blood gets too high or too low, baroreceptors will detect this and send it to the cardiac control center in your brain, and your brain will either use vasoconstriction, which will try to increase blood pressure, or via vasodilation, which will try and decrease blood pressure. At rest, your heart is naturally around 60 to 80 beats per minute. In class, we took 2 tests to measure students' heart rate, blood pressure, breathing rate, temperature, and blood lactate. Here are the results of the heart rate and the blood pressure of both tests. One test was the multi-stage test, like the bleep test, where every 2 levels we measured them. The other test was the Wingate test, where someone is in a static bike and pedals as hard as they can for 20 seconds. As you can see, the heart rate in the multi-stage test goes up by a lot from the pre-test, as it gradually increases when the test starts. It increases due to the carbon dioxide produced when running and the amount of oxygen needed for the muscles. Also, the pre-test heart rate is a bit higher than the rest due to perhaps nerves from the exercise or where the brain is preparing for the exercise by increasing the heart rate. This is different to the Wingate test, as there is a much higher intensity where the student will be cycling at maximum. This shows that at the post-test the heart rate has risen dramatically. Therefore, at the end of the 20 seconds at maximal exercise, the heart rate has gone up to 120 beats per minute. The other measurement we had was the blood pressure of the student exercising. The results of the multi-stage test have shown that the blood pressure stays quite similar where it goes up and down, but it ends up a bit higher than at the start. These results show that students have quite low blood pressure, which is healthy, but we don't want it to go too low as something could be wrong with the blood flow. At the post-test, the blood pressure is at 138 to 97, which is around the same as someone at rest, showing that the student has good fitness. This is in contrast with the Wingate test because, as there is such high intensity, the student's systolic blood pressure has risen dramatically due to the faster contraction of the heart, forcing the blood out, where the diastolic blood pressure is decreased. This is unusual as it will normally go up, but as it is still around 40 moles of mercury, then it is not seen as a big problem. Overall, the heart rate can also estimate the cardiac output, as the average stroke volume at submaximal is 120 millimeters. So you can times the heart rate at level 4 to level 8 at any of them 4 levels by 100, and you can find your cardiac output from the multi-stage test. The same would apply for the Wingate test, but you would need your heart rate. You would use the heart rate at the post-test instead. In football, your cardiac output will be going up and down as you will be running at different intensities depending on what position you play. If you're a central midfielder, your heart should be constantly rising, as the central midfielders are usually players that cover the most ground, but at a slightly lower intensity as perhaps a winger. However, wingers do not run constantly. Midfielders should also have more stamina, which means their stroke volume is increased, as they would have stronger heart and the muscles would be able to get more oxygen. Therefore, the midfielders, the cardiac output should be the highest, as they be running the most, causing an increase in the heart rate and having a high stroke volume. On the other hand, this is completely different to a position such as a goalkeeper, as they do not have to run much at all. Their heart rate will mainly be low for the duration of the match, unless he has to do high intensity work such as a triple save or a sprint out from his goal. But that can only happen once around once a match. As a result of this, their cardiac output may be low due to the heart rate. However, in their training sessions, they are still training to be fit. Therefore, their stroke volume may be quite high, depending on how hard they train.